suppose it's been certainly quite a few years since I was in Bolton Street, but I've still have nightmares about Eddie Fallon and concrete. And back then, I think I was more into the nightlife around the city than into what Eddie was talking about in concrete design and concrete technology. Today, my wife says that I'm probably equally as boring as Eddie Fallon was back then about concrete, so we don't talk about it too much at home. So I was hoping to give you a bit of an update on what we do and who we are, and I suppose what the relevance of Shay is to the precast industry in the UK and Ireland. As Kieran says, some of what we've done over the last maybe 10 years has been disruptive, I suppose, in the precast market, and so it's a little bit about the business and sort of business policy or business what we've tried to do, as well as the precast itself. If there's any really technical questions, I've got Steve Lowe. Steve Lowe is a graduate from Cambridge. He's got a master's in the philosophy of bridge design, so we bring him to technical meetings, but we don't bring him to the pub because he's not really that interesting. So, but if anybody's got a question, anyway, Steve is the one for the technical ones. So just going to outline sort of who we are, what we do, what our capabilities are, and some of our projects, and then just to talk about the future. And despite what you might hear, I think the future is pretty bright for civil engineers, structural engineers, and the precast industry. So we're a family firm based outside Mullingar, County Westmeath. My father started the business about 40 years ago. He started as a civil engineering contractor, and I suppose quickly realised that precast was faster, better, more economical, and he could move to sites much quicker. So started a precast business in the mid-70s. Today our group structure is quite a bit bigger. So we still have our main factory in Raharney. That's where we call a head office. We still have a contracting arm which does a lot of installation. We call Shay Limited. Then we have IStructE, which is our sort of residential, commercial business. It does sort of solid wall, twin wall type stuff. Structural Research is our sort of design company within the group. So if you want something designed, it's designed by Structural Research, where we have a pretty extensive team. I suppose we put that together because of all the new developments with BIM, and just try and keep it focused on sort of keeping the latest developments ahead of them. And then Evans Precast Concrete is architectural business that we have outside Derby in the UK. There's about 80 people working there. So they do specialise in sort of building facades. So a lot of buildings around London would have Evans Precast, and I've got one or two more pictures of stuff that they do here in the presentation. So the main factory is the biggest. I think it's the biggest in Ireland. It would be probably the biggest in Ireland. 38-acre manufacturing. We have our own sand and aggregate deposit, 2 batching plants, and they've pre-stressing for bridge beams up to 4,000 tonnes. It's probably the biggest, again, it is the biggest in Ireland and the UK, and probably can do beams much larger than anything that we need for today's market. We pour between 250 and 300 cubic metres of concrete a day in bespoke pieces. So while we make W beams or big bridge beams up to, with 40 cubes of concrete in them, we make small pieces for network rail projects that might only be a tonne, or we don't like anything less than a tonne weight because can we just cause trouble. So that's Shay Precast. Shay Limited then is a contracting company, as I said. The lads, we've guys that are working for that company for 40 years, and I suppose installation and precast and some of the it's almost like a dying art, and the guys that know how to rig stuff properly and do installations, so we do a lot of sewage treatment works, reservoirs, and then we do a lot of lift shafts and stair cores and just buildings. And if you want a bridge installed, the guys just go out in their vans and they just go install a bridge. It's easy for them because they're doing it every week. IStructE is down in Kill in County Kildare. IStructE is a fully automated factory. It makes so basically we upload the drawings from Tekla or some 3D program, goes onto the robot. The robot puts the magnets on the table in the right shape, doors and windows, whatever's needed. And it moves on to the steel, and steel is placed automatically, and then we have to have somebody do the concrete. But pretty much cutting edge, state of the art anyway. It's projects we're involved in at the moment. We're doing 60 houses out in Ongar. We're doing 3 5-story apartment blocks up in Blanchardstown. We just did a hospital in Cambridge. What else are we doing? We're doing a school in Galway and a nursing home in somewhere, Fingal somewhere as well. So it's kind of, it's the biggest factory of its size in Ireland, and there's one bigger in the UK that just does that type. So it only does 150 thick panels or 200 thick panels or twin wall. So if you have a house or an apartment block or something like that, it has to be one of those 3 products, or we can't do it. Which took us a while to learn that, actually, because the lads were trying to sell 250 thick panels or 300 thick panels, but the system just can't do it. But it's amazing to see it once the drawing is uploaded, press the button, and then everything starts working, and it spits it out. For instance, those 3 5-story apartment blocks have to be finished by Christmas, and the drawings will be approved, I think, this Friday, and we have to have them up and installed by Christmas. And if you didn't have a factory like this, you definitely couldn't do it. I said structural research is our sort of design department. We used to have it all integrated. Everybody had their own little design department in each factory or each part of the business, and these days we're trying to put it all together so there's a bit of CPD, a bit of learning, try to keep up to date with. We use a lot of Tekla and just different design programs, and just wrapping it all together in structural research is just really good for development of the people in that business. Evans is the newest member of the family. Evans is most famous for this thing, which is a white head outside Liverpool. You've probably never seen it, but if you're driving on the M57 in outside Liverpool, you see this 22-metre high white head sticking out of the top of a hill. It's an iconic structure. They won loads of awards for it. But normal business for them is sort of your 10-story office block or apartment block in London Dock, or Whitechapel, these sort of places where a lot of development going on around the city of London. They also do a lot of sort of hard landscape and specialists. So whatever colour you want, black, polished, acid etched, whatever you want. Evans is the place that we go for that. So if somebody in Ireland is looking for something like that, it's made in the UK and brought back. But I suppose most of the business is over there. Every company has a mission statement, and ours has always been that we've a commitment to deliver infrastructure on time, and this has been sort of key to our success over the years. How important a mission statement is, your clients measure you on it every day. Again, vision. I wouldn't say we're visionary in anything, but I suppose we are customer focused, and we try to get everybody involved in sort of the dialogue with the customer, and continuous business improvement, and then sort of CPD, and trying to get our guys trained up and try to improve everybody in the organisation. We work a lot on culture. I know the old days, I suppose the precast industry was like construction, maybe a bad reputation, sort of a hard reputation, and these days we work a lot on trying to develop a culture where everybody feels like it's somewhere that they're delighted to go to work. We do this through a load of different ways of supporting local organisations, dinners out, social events, all that sort of thing. It's not like Google, but it's trying to be a bit like Google. And we work a lot about our values, so there's no more screaming or anything like that we're used to, from construction sites years ago. Everything is about sort of trying to develop a team, and I'll just talk a bit more on that in a while. So just Shay Murtagh established in 1971. There's some old black and white pictures from the very start. we have ISO 9001, OHAS 18000 and 14000. We're the first company in Ireland to get all management systems, and I suppose integrated the whole lot then. In 2004 we started exporting to the UK, and that was just some small box culverts, but really we expanded in 2007, just before the crash, or around the same time as the crash anyway. It's funny because when we went to the UK, they all thought that we're in the middle of a recession, and I was having to explain to people that a recession was when the phone didn't ring at all, and that was what it was like at home. So, but we were quite lucky because there was a good opening in the UK at the time, and we started really with the Tyne Tunnel in Newcastle with a company called Bouygues, and that was a major project at the time. I remember going up the A1M with 19 loads of bridge beams coming behind me and praying that no guard or no policeman would stick his hand out to stop us, because the penalties at the time were huge for not turning up. What I didn't realise at the time was nobody else could do it, and nobody else would have been in front of the truck trying to make sure it was going to be there on a Sunday morning. The rest of the products, I mean, people in the industry know Shay Murtagh for bridge beams, for culverts, for tanks. I suppose they don't know us for twin wall, residential, I suppose commercial. We also have a reinforced soil business, which is Hexlock and Gridlock, and then sort of hard landscape and public art. Shay Murtagh is not really a name that's synonymous with public art in the past, but we can do that these days. In the market, I suppose, again, from 2007 onwards, I mean, the precast market just crashed here, so we found ourselves having to depend more on the UK. Today, about 82% of our production is in sterling, of our sales are in sterling, and I have a list of clients there, sort of our major clients. Though everything we make is bespoke, you tend to find it's the same people sort of reordering all the time. So if you have a relationship with a particular guy in Bam Nuttall in 2008, well, it turns out he's probably running a whole scheme of projects these days. Same with any of the clients, really. Those guys move up very quickly in the UK through the ranks, so they become sort of key customers these days. So just in terms of capabilities, talked about design, obviously manufacturing, the factories, logistics and installation, and so that's the whole process for precast. For whatever precast you need to get the precaster involved in design, and obviously he has to make it, but nobody buys precast ex works, so you have to do the logistics. The precaster has to do the logistics and often has to do the installation. So just on design, so I think 75% of our stuff is drawn now in 3D in Tekla. We use Tekla, we tried Revit, we didn't find that very comfortable or compatible with what we were doing. We use Tekla. Our clients now send in an IFC file, we'll change it into our model, we try and convince them to use a Tekla model, but if they don't, we transfer it back. So I mean, this whole 3D design has made life so much easier for the guys in the factory, for the guys in installation, and obviously for the design itself, when we can see the clashes and just the issues, and just to pick slimmer sections or a new idea. We'd often just throw a model up on the wall and just decide to take it apart to see what we can do to make it just for some reason to make it lighter because of the piling or something like that. And often the type of precast you choose will affect lots of things around the whole project, not just the precast itself. All sorts of beams, from sort of the heaviest piece we've ever made is 200 tons, and we go back to, as I say, small stuff, 1 ton. We do all types of U-beams and bridge beams, but what people again don't know us for is last year we did 15 steel bridges, because often steel bridges have as much concrete as a concrete bridge, would you believe? So that's where we need a particularly thin section where the client just for some reason cannot accept a deeper section. So we're going to have to go with a steel composite deck, which often when you're doing sort of retrofit or replacement bridges, you're going to have to look at whatever solution you can use as engineers for the solution. In terms of bridge replacements, last year we did 67 bridge replacements on the Network Rail in the UK. We did about 12 for Irish Rail. So it's quite a good part of the business in that, you know, sort of every week and a half, we've 2 bridges going out. So it's and each one of those is really, really challenging and really interesting from a manufacturer point of view, design point of view, and then the whole logistics and challenging. Christmas Day is the busiest day of the year for the logistics team, but like 2 weeks before is the busiest for the factories, because in the UK the rail lines close down at Christmas. So the busiest we've had is 12 bridges on Christmas Day. So 172 trailers moving on Christmas Day. It was mental. So that brings us on to logistics. So we've about 120 odd trailers, everything from sort of your standard 40-foot trailers right through to the sort of modular stuff that you would only see on the road if you're at night. These sort of things, it's a 45-metre long beam, W19 going up the M6. In the UK we go up during the day, but in Ireland they have to be at night. So if you're on the M4 at night, you'll see a load of Shay trucks crawling up the road pretty slow. So we deliver, that one's going to the Mersey Gateway bridge. There's 256 beams on the Mersey Gateway, and they're all longer than 38 metres. So it's a real logistical challenge as well as the manufacture. So the next bit was just on installation, and what you see here on the left-hand side is a stair core and a lift shaft. So we do precast stair cores and lift shafts, and they go in again all over the UK. But I suppose what the installation team's working an awful lot on is the concrete tanks. Concrete tanks are precast post-tensioned tanks. It's actually, I did my thesis on it. It's in the library still. I must look it up to see if it's still there. We've been doing precast post-tension tanks in Ireland for 40 years, but they're really only catching on in the UK lately. In the UK there was a lot of issues around post-tension and back in the 70s, so it's really not it hasn't been that popular, but so it's taken quite a while to get them to sort of understand the system and what we do. So the tank panels are much bigger these days than they were back in the 70s. These days they're put up by big cranes, and but they can be put up in 2 or 3 days. Typically a team of, on this project surely, there's 5 guys working on site, and they have 3 tanks up in 3 weeks, and the client is wondering why he hasn't used this his whole life. So I think it's just another part of sort of what we do. There's a little bit of, in the post-tensioning, there's a little bit of I suppose, what would you call it? I wouldn't say black box technology, but I suppose there's a little bit of thinking around about the post-tension design in those circular tanks. We also, Steve knows a good bit about it, but we're doing some rectangular post-tension tanks at the moment, and they're really, really interesting as well. We've been talking about this for about 10 years, so we finally have the first ones going up at the moment. In terms of operations, I suppose, when you're running at the sort of levels of production that we do, supply chain is really important. So it's really important that you have, obviously you'll have your concrete and your steel and stuff like that, but all the accessories, connections, everything that's required, you need to have that, or you need to have your supply chain on hand to have it there. So we work a lot with our suppliers to make sure that we have everything available. We've huge stocks of things like lifters and things like that. We have a ERP system, enterprise resource planning sort of a system, tells you exactly what's going on. Really important again in the sort of multi-factory environment where you're trying to coordinate pieces from each factory. And design and when design's going to come through. So we call it Jarvis, and we're continually updating it. I suppose we have some future plans for that I'll maybe outline in a minute. And then of course the whole integrated management system that I spoke about. Quality, environmental and health and safety. For CE marking, we're fully it's a list of 9 categories where concrete products have to be CE marked these days. So every manufacturer has to be able to do the CE mark, and it's quite stringent sort of tests in place, and compliance with them is quite onerous. In terms of training and health and safety, we currently have an apprenticeship program running with at Loan Training Centre, where we have 14 guys being trained to be precasters at the moment. It's a bit of an unusual step, but I suppose we need people with certain skills, and they're probably not coming in off the street anymore. So we've a 7-month program with at Loan Training Centre. This is the first year of it, and sort of a way of trying to encourage people to come in and actually look for jobs, and then train them up to work for ourselves, or they could get a work with any precast factory, I suppose. So some of the projects that we do then, as I said to you, Network Rail are a key client, and this one here is typical of what we do. It's sorry about the music. MPB structures, but it's box beams and sitting on top of steel beams. So the bridge has been demolished previous week, and there's a 72-hour 72-hour possession to install the new bridge. So what happens is the drones arrive in with us, and we start manufacturing it. We assemble the whole thing in the factory. Once it's complete, assemble the whole lot in the factory. Client comes over to take a look, and once they sign off and everything, it's all loaded onto trucks and goes to site to be installed. So although the guys are putting it together here, they know that it already fits. All they have to do is make sure that they put the first piece in the right place, which sometimes they don't put the piece in the right place, but so we don't actually get too many calls, and our guys usually don't have to go to site. We usually we take a video of the whole lot going together, give them the timings, and tell them sort of how long it's going to take. Again, you see here these are blue bricks, blue engineering bricks that we have to use on this. Network Rail specification is engineering brick, and depending on the area, it'll be blue, red, different types of pointing, different types of whatever. We have 5 brickies working in our factory now for the last 6 years, just non-stop, just doing brick. And nobody wants to know about brick slips or anything like that. They just want full brick, which is a bit amazing. And another project that just got some local awards from the local council and stuff. Probably doesn't look too bad. The next project is the Crossrail tunnel. Crossrail was the biggest project in Europe for a couple of years there. So we got the contract to manufacture the tunnel segments for what we would say is the most difficult part of the project. It was a bit underneath the Thames, and definitely the most challenging from a geological point of view. 27,200 pieces, and very, very challenging. 36% GGBS in the mix, 30 kgs of steel fibres in there's no conventional rebar, just 30 kgs of steel fibres. The tolerance on each piece was 0.5 millimetre. So I'll give you an example how that affects you. When we came back after Christmas, the place was cold and the heating hadn't been on, so the moulds were out of spec. So we had to wait 3 days to heat up the moulds to get them back into spec so we could start casting. Definitely a very, very challenging project. The project went faster than normal. Usually tunnel projects are huge delays. This one actually went faster, so we had to double cast. So now we've got a very, very onerous client with 30 36% GGBS, no conventional reinforcement, and we need to cast twice a day to try and make the program. And we actually did it, which shocked most of us. But from a logistics point of view, there was 3,600 truckloads in it. There was another complication. We had another tunnel going on at the same time down in the Corb. That was tunnels. This is the project director for Hochtief. With the glasses on. He's now head of Hochtief Europe, and that's the day when the TBM comes through the end of the tunnel. Yeah, so it's a very, very interesting project. You could talk about it for 2 hours on its own without anything else. Just the testing on the fire test on the concrete was the first time it had ever been used. 1100 degrees for 45 minutes, just to make sure it's not going to. As I say, you could do a PhD on the tunnel itself. Structure 17 on the M50 is the one with the curvy bridge that you talk about, right? There's 38 curved beams, post-tensioned. Again, just in Ireland with the post-tensioning situation. First time in quite a while that post-tensioning had been used in this type of structure. And so we had some pretty rigorous requirements from the client around proving that the grouting was up to spec. Of course, the grouting technology has moved on so much in the 20 years since the last one was done. Precast permanent formwork with a lattice was used over the beams. The biggest cantilever we got was, I think, was 3.7 meters with no support. So just using a lattice, a steel lattice. Again, I could talk about it all day. But you're trying to do that project with a canal, live railway line, 4 lanes of traffic, and no room, basically. So precast was really the only option for it. And the largest beam on it was, in terms of the curve, 36 meters long and 6 meters wide in a rectangle, if you know what I mean. And an interesting fact on it was when we did the post-tensioning, the beams would close the curve a little bit. So we had to work out how much the concrete was going to shrink into a banana, if you know what I mean, as we were casting. It was really challenging, and then we had to try and get the joints as tight as possible. And of course, when the installation sequence came out, everybody was like, oh no, because we had that last beam that had to fit in between everything else. And you were hoping it was going to fit, but it actually did, and it looks quite well anyway. Again, we've won a couple of awards on this, and for instance, High Speed 2 will be using this project for this type of design for some of the projects in the UK. Really simple one here, Land and Marine, Blackpool. The people of Blackpool want to send their sewage a little bit closer to the REC, so they're putting a new, to the Irish coast, they're putting in a new outfall, and again, really tough spec on the concrete, but interesting way they're doing it. They put together the pipe in Holyhead, sealed it up, put on some collars, some weights on top, brought it over to Blackpool, and then basically burst the pipe, let it fall, sink down, and then put the rest of the collars on. So in terms of, for us, it's a huge amount of these weights, and I suppose we have another one at the moment with I think it's 1,200 pieces that are 27 tons each, just pipe weights. Amazing, just the scale of the projects that they do. Reading, Kieran spoke about Reading Viaduct. Reading Area Improvement project was a massive one for us, but we got the Concrete Society Award in the UK for it because of the scale of the project. There was 25 spans, 25 metres long each. There was, altogether there was over 500 bridge beams brought in right into the middle of Reading. There was 178 culverts, 28 tonne each on the project. So they're trying to build this viaduct in between two rail lines, and you see the complications with the jibs of the cranes, everything. And then the police told us that they want all the deliveries in hours of daylight. So the first day we went in with 5 trucks, 25 metres long, and they said, no more deliveries during the day, we want them at night now. So we, but just typical of what they try to do is sort of in the UK construction sector. I mean, no matter how complicated it is, they seem to put their mind to it and try to deliver it. Yeah, there's a great shot here of the installation of the culverts in a minute, where they've got a 1,200-ton crawler crane. I hadn't even seen something like it before, and they're just putting in a couple of culverts every day. You know, it's just slightly different thinking than the way we would probably do it ourselves. So this construction site is right in the middle of Reading, and it's on the Great Western Rail line, sort of from London to Cardiff to Bristol. So it's really busy with train traffic. Today, if you go to Reading, I mean, it looks really well. It does look new. It doesn't look old, but yeah. I'm not sure why this one is in here, but anyway, the little outfall. I think the lady in marketing that did this liked the project or something. She, again, up in Glasgow, the people of Glasgow thought this was a great job for the Environment Agency up there, but the rest of us are going, it was a nightmare. More of this sort of architectural like concrete, I suppose. It's a good one here, Summerstown Community Hub. Steve will remember this one because it was quite a challenge from a design point of view, because we're traditionally designing bridges for our road traffic or whatever. This one had a building on top, and the structure was timber structure, wasn't it? And we had some strange point loads arriving in places that we didn't want them, and we couldn't move the beams. Essentially what happened was there was 2 tower blocks, blocks of flats or whatever, that were divided by dual carriageway back in the 60s, and in the 70s the place, I suppose, got a bit run down, and they started to shoot each other from one block to the other. So to try and rejoin the community, they decided to build a bridge and then put this community centre over. And I think we all regretted taking that phone call from the architect that day, because it just turned into one of these just these massive projects. But you know, we were invited back and thanks for all our help anyway, and they keep talking about us as if we're after linking the community and stopping the hatred from one tower block to another. But I think you'll agree that the project looks really well. I think it was U3s, wasn't it, with a 2-span bridge anyway, down in Portsmouth. Just a little bit about the future. I mean, you talked a lot about Shay and some of the projects we're doing, but just I suppose we as I said, the precast industry maybe had a bad reputation in the past, and we need to get ourselves a little bit more up like a Google, or like maybe not Google, maybe one of the medical device companies or something like that. So we need to work on sort of our reporting systems, on our quality, and just to make it a bit more like like those sort of industries. So, I mean, I talked a bit about Jarvis, our ERP system, but the lads are working on now giving the clients access. So if you're an architect, or you're all engineers, so if you're a structural engineer in a project, so that you'll be able to log on and see exactly where your project is going through the system, and whatever it is, using the models, the BIM models, the technical model, you'll be able to make some changes sort of live, rather than having these sort of drop dead days where everything is done on a certain day. Everything should be much more live, and then if there's any issues with costs or anything, or any efficiencies to be gained, you should be able to make those changes. Obviously we're working, and everybody in the precast industry is trying to work more towards BIM. The 3D modeling, we've all seen huge advances in it, huge advantages in it. The difficulty is sort of getting trained people coming from the colleges, coming in so that they know they're up to some sort of level on it. And I know the colleges are working on that at the moment, but just as an issue around people there. Yeah, I suppose we work. I suppose it's our company sort of goal to keep working with the colleges, working with the training centres to try and get that sort of those sort of people we want, and to get them coming in with the sort of teamwork ideas that we have ourselves. We're working on a Tekla warehouse. I'm not sure exactly what a Tekla warehouse is, but it's online apparently, and sort of we have an awful lot of information. So you as designers will be out there and you'll be looking for information. Well, we're trying to give it to you, make it as easy as possible to give it to you. Every project we've done, thousands and thousands and thousands of projects, different levels and complexity. They should be available to you guys, so that you're able to. You don't have to reinvent the wheel as you're in industry. So with regard to culture, then we have a lot of. What we found was the guys in the factory didn't really know what was going on the site. So we've an internal Facebook site that everybody sort of uploads what's going on site. So every day you get updates on Facebook, and the guys in the factories sort of really appreciate to see what their final products look like. It's a really important thing from just around engagement, because even myself, I don't get to the sites anymore to see each individual one. The Allcrete is, as I said, an automated factory, but we're working a lot with trying to figure out how we can use robotics in sort of bespoke concrete. We've our first robot finally going into Rahani in 4 weeks' time. But I think there's a lot of stuff that we can work at to try and use sort of robots and that sort of newer technologies in the manufacturing process to make it a little bit more, maybe a little bit more economical, maybe a little bit easier for the guys on site, and hopefully improve quality. I suppose the trouble with that is there's nobody else doing it, so you have to kind of do it. You can't just go and buy something. So I just wanted to talk a little bit about some of the projects going forward. So the first one I wanted to talk about was High-Speed 2. I don't know if everybody's aware of High-Speed 2. So High-Speed 2 is a £52 billion project in the UK. It's the new rail line between London and Birmingham, going up to Manchester and Sheffield, and up to Leeds. So phase 1 is 140 miles of track, and that's all going ahead at the moment. The contractors are pricing different packages at the moment. I have some figures here in terms of phase 1. They've got 15.6 billion. That's actually gone up a little bit now. $1 billion is nothing over in terms of this project. It started out at 30, now it's at 52. I can't keep up with. They keep on moving it up and down. So only 7.5 is spent on the rolling stock, so the rest of it's all going to be spent on the civils and the electrical and I suppose the land. This is it divided out. So there's 2.9 billion in tunnels, 2.7 billion in the surface route. That's bridges, viaducts, stations is 2.6 billion, 600 million enabling works. Design services, 350 million, massive packages. The Board tunnel is 82 kilometres long, 7.55 internal diameter. I put it up there just. The Channel Tunnel was 7.6, and so it's about the same size as the Channel Tunnel. And I'm not sure if everybody in the industry here kind of understands the scale of the project. It's just massive. Even the 11 vent shafts would have been a great order a couple of years ago. So that's the tunnel. A lot of this information is available. If it's not online, I can send it. In terms of viaducts, this one here is the Colne Valley Viaduct. It's 3.35 kilometres long. This 75 viaducts, 20 something kilometres, so everything from 50 metres to 3.35 kilometres, 300 culverts. The figures are just massive for it. In terms of stations, there's only 4 stations, but Euston Station, again to give you an idea of the scale, 1,200 houses have to be moved for the development of Euston Station. And the whole thing is costing 2.7 billion for the 4 stations, Euston being the biggest one. So I suppose to give you an idea on the where that project is at the moment, there's 9 groups that are tendering it at the moment. The tender award will be next August, September, and be on site in 2018, and that won't be affected by Brexit or anything else or anything the Euro guys do. This is committed. I had a meeting with the Minister or the Secretary of Transport over there 2 weeks before Theresa May took over, and then he assured me it was going ahead. He lost his job, so I had to go to the new guy then, and he says it's okay. So 2 weeks later, he's still in a job, so that's okay. But it's just a massive project. But it's not the only massive project in the UK. That's why I think the future is so bright for Shay Murtagh, but not only for Shay Murtagh, but for the whole industry, for the whole precast industry. The fact is, if the whole precast industry in the UK and Ireland work together for 2 years, we can probably deliver High Speed 2, which is completely unheard of that we would all work together, of course. But the other thing is that the project's going to be going over 5 years. So it really doesn't, there's still plenty of capacity for everybody else, for all the other projects. Until we look down through the list and we look at Hinkley Point, the nuclear power station down in Somerset, 24 billion. Massive. I have a whole another load of information on the scale of that. CP5 is the control period 5, so that's the Network Rail spending. It's 2.6 billion there. That's all that's left in this one. The next one is, I think the next one's 6 billion, which starts in a year and a half time or 2 years time. This is the bridge replacements and electrification on the rail line over there. Massive. Thames Tideway Tunnel, 4.2 billion. It's on site at the moment. It's 20 kilometres of tunnel underneath the River Thames. Massive project. A great one to be involved in at the moment. The A14 is 1.5 billion. A14 Cambridge to Huntington. Huge road project. So there's 23 structures on it. There's one 65 metre span, one really good one. But just this gives you an idea of the sort of projects that are ongoing in the UK. Just the normal programme for enhancements, like fix up a bridge, widen a bridge, is 600 million with the Highways Agency. And then you've got this one, the Heathrow Western Access Tunnel, 800 million. And the Transpennine route is a route from Manchester to Leeds, 800 million pounds. I can tell you now that that's going to be about 2 billion, because there's no way that they're going to get away with 800. So I suppose the future is very bright for precast, but also for the sort of civil engineering sector as a whole, given the level of work that's coming down the line. Unfortunately, most of it is about an hour and a plane from here. So over the last 10 years, you sort of got used to sort of on the plane, off the plane, do 4 meetings and then get back on. But you know, the market in Ireland is just not going to be big enough for a long time for structural engineers. We work an awful lot on Skype and everything else, so I mean, we can be sitting anywhere. And you know, if you're getting a train from Heathrow Express, you're doing a Skype meeting on the way in, and it's just the way we all have to work in the future. I think mobile working is becoming much more like normal routine. So I don't know if anybody has any questions on any of that.
Thanks, Grant. I thought it was a fantastic lecture, and just the scale of operations and the organisation behind it is phenomenal. And it's real credit to Shay Murtagh how you've expanded into the UK and you're working on some of the leading infrastructure projects in the UK, and they're some of the largest projects in the world, to be quite honest. Crossrail itself was one of the largest projects in the world for a long time. Is there any questions from the floor before we get stuck into it? I might ask, just wanted to kick off the, let's say technically speaking, it might be a question for Steve, but say concretes are getting stronger and stronger, and Europol is kind of looking at higher strength concretes as well, and how do you see that impacting on precast concrete innovation? If we go up to 80, 90, 100 new concrete?
Thanks, Kieran. Yeah, there certainly is a lot of scope for high strength concrete for sure. I mean, particularly with pre-stressed concrete, because for most pre-stressed concrete designs that we would do, the stress limit checks would govern for strand layouts, for section size, for all the rest of it. And those stress limit checks are always going to be they're a function of the concrete grade. So yeah, particularly with pre-stressed design, we're finding that there's huge benefit from higher strength concretes. And also with Eurocode implementation as well too, even for reinforced concrete as well too, there are also now stress limit checks that can kick in and can govern for thinner sections. And we're trying to get away with thinnest section possible, minimizing section size, weight for transportation, for installation. Again, those stress limit checks can kick in, so that high strength concrete really does come into play on many facets of precast concrete design. So, and yes, we can C50-60 now is really kind of our bare minimum, to be honest with you, base. Well, C40-50 is our bare minimum, really, isn't it? But C50-60 is frequently specified now, but we get up to, we're very comfortable specifying all the way up to 80 cube at the moment, strength, without any real significant cost implications. But yeah, there certainly is, the technology is there, the production facilities are certainly there to go to those very high grades of concrete without any tremendous difficulty. And again, there's lots of complaints about the Eurocodes from us. There's some frustrations, but it definitely has been a positive of the Eurocodes. There's a lot more scope within the Eurocodes for you to directly, explicitly address the benefits and how you incorporate the use of higher strength concrete. So,
Thanks, Steve.
great, thanks, Karen.
Any questions from the floor?
Just the high-speed 2 project, saying that it's currently at tender stage, but have been appointed about a job that you look at in the future. Are you still tendering it yourselves?
Yeah, I mean, I suppose the way that works is or the way this project, they talk about it as being a collaborative process. So 9 JVs expressed an interest in the project. Those 9 JVs have been given different parts of the project to price, so a little bit of tunnel, a little bit of bridge, whatever, and so those guys are currently pricing that. When they go back with theirs, then the client will assess. Not really so much on cost. We talk a lot about price here in Ireland, but over there it's more like, well, how are we all going to get together? Are we going to get on together? Are we going to be fighting? What's our relationship going to be like? So if they like the relationship, then you're going to get the awarded. The price is only a small bit, but they do need to have a baseline for price. We would have given a lot of advice on the design of the precast. So in the packages, they've specified precast. So it would be crazy for somebody not to go with precast if the client is saying you have to go precast. So yeah, so I suppose when I do see them coming out, they won't be entirely unfamiliar to me. So, but it's not ours. We don't have it. So we'll be, once the contractor gets awarded, well then we tender as normal for it. But really the benchmark is very high for everything, quality. And then that whole collaboration thing, thing called BS 11,000 on collaboration, is just basically how you talk to each other. So I think if you don't have that, you're probably not going to get awarded anything.
I think high speed 2 is a great opportunity for all of us in Ireland. You know, in fact, a lot of large companies are already working on high speed 2. My own company's working on it on one of the tender packages, and in the UK there's a big worry of just that they don't have the skills at the moment in terms of the number of engineers in the UK to deliver just the scale of the works you outline on the page there, Kieran, is massive. You know, in terms of there's probably 100 billion euros worth of work, and 100 billion sterling maybe. And even with Brexit, there's a feeling that, you know, as a way of keeping their economy booming, that they'll refocus on infrastructure, and hopefully, you know, there'll be difference to the Irish-based engineers. And as you say, working in the UK is only a plane ride. We've all got used to that in the past 10 years, just flying backwards and forwards. I'm very interested in the curved beams on the M50, and they were in situ post-tensioned. Is that so? You in situ post, or you cast them in the yard?
Yes.
And they were in situ post-tensioned, and then once the whole thing was stressed and it was carted off.
Yes.
Was there any continuity tendons going through the structure then, or how did you?
Just through the joints. So the post tension on site. So once we made the beam, we left it there until it got to 50 or 60 Newton, and then we put in the ducts, post tension them, grouted them, and then we could start bringing it to site. Then once it got to site, then we had special anchors in the ends, which just linked the beams. Not the most ideal design in the world, in that it was kind of a compromise between trying to inspect the post tensioning through the joint. Everybody was sure what we were doing in the factory was perfect, so but they needed to inspect those post tensioning ducts on site. So it was particularly difficult, but because they need to be inspected, we needed to take them up quite high in the beam. Remember, they were about 600 up, and so that meant we had to have double the post tensioning in it. Because we lost that lever arm, didn't we? Do you remember? Yeah. Okay, sorry. Okay. Okay, sorry about that.
Yeah, that seems to be a lean for high speed 2 as well too. There's a lot of discussion and debate on local post tensioning across stitches as well too. It's really almost like more of an external post tensioning as well too. So there's a detail that we're not as familiar with in the UK and Ireland, but certainly a lot of precedent with that in the States, and also Spain and Portugal as well too. So the continent. So yeah, that definitely seems to be something that'll be increasingly common, I think.
That's right. The spans can be spans on some of the viaducts are quite large for high speed too. So
each span. So
again, we've
the stitch across the span. So
Any further questions from the floor?
Just on some of your kind of the precast walls, twin wall and that, like what we're finding inner city at the moment is the logistics involved in installing a precast wall. You're limited with your tower crane, and you said that obviously you guys are, you know, fully set up to do everything yourselves. Like, I suppose for like where we're limited is lifting solid panels, so then it's twin wall typically. Like, are you guys seeing a change in any of that, or you know? Obviously the program games with precast walls versus in situ are with everyone involved in trying to be the first to get up quickly as least. So are you guys seeing a shift at all yet coming your way, or is
from solid to twin?
from in situ to be it solid or twin wall precast?
Well, okay. So at the moment there's an issue with trying to get twin wall or precast panels in Ireland. And the UK, because again, most people are supplying the UK, and typically your prices are 40% there over there. You're getting 40% more, so everybody's more interested in the UK market. But I suppose with Allcrete online now, we can really throw out the twin wall, and I think we're kind of pushing that over the next while. A little bit more, so it takes there's a bit of a lag between when stuff is available. So you really need to tell people that in 6 months' time we were available to make twin wall, and then they'll start designing it into their structures then. So the 5 story blocks we're doing in Blanchardstown are solid wall, 200 thick. It's probably the best solution for where it is not restricted by the tower crane. So the panels are actually big. They're, I think they're 22-ton panels, because they're trying to cover a whole wall, and for the speed, Whereas if you're doing something in the middle of the city centre with a tower crane, you need something 3-4 ton. So you just need short panels. So the cost of installation goes up, but the square metre price per the panel shouldn't vary all that. But with Allcrete, what we're really looking for is we're looking for just to sell the panels, deliver to site, and somebody else put them up, because the factory's kitted out just to throw them out. So if you have a bin, if you have a Tekla design, throw it in, and we can just load up the panels straight away. But clients don't do that. They always want a window or the sockets, the bloody electrical sockets.
And then you want to.
Yeah. So.
I don't think there's much momentum for twin walls at the moment, though. I think we're hoping there is. I mean, they're much more, structurally, they're far more economical approach towards higher walls. Once you start getting 3-4 meters, especially with sloping backfill to your retaining walls, the twin walls become a much more structurally efficient solution. And they'll certainly be lighter than your traditional solid L walls, and that, of course, lightness is what you want for installation as well, too. So, but I don't think that momentum has really gathered much steam yet, so hopefully it will. So.
Any questions? Further questions?
We've seen in recent years a lot of companies from Europe are tendering for civil structural works in Ireland. For example, Samuel Beck Bridge was fabricated in the Netherlands. Do you see any work to be done in Europe by Irish companies?
Yeah, in certain areas. Actually, we have a project in Poland coming up in sort of reinforced soil. Again, probably not going to be able to go out and build a road out there, but we can sell them this technology. I suppose we have a lot of projects done with the reinforced soil, so we're just doing a design and showing them what to do and letting them off. It's great business for Ireland. The steel industry, unfortunately, I mean, it's very strong in Netherlands and Portugal as well, and we were just discussing it earlier on. At the moment, there's quite a few of those steel bridges. We get them done here for Network Rail, but they tend to be, sort of top dollar stuff. Whereas when you get the likes of Samuel Beckett, you need to be very. It's such a big project. I suppose it's. I think if anybody from Ireland is moving to Europe, you need to be moving with some sort of edge on the market. I mean, it's not good enough to say we just have our can-do attitude. It probably gets through the UK quite quickly, but but in Europe, it can be difficult. We'll see this project in Poland anyway. We'll see how it goes.
Any further questions? Talking about tolerance as a 0.5 millimetre, I don't know how you even go about achieving a 0.5 millimetre tolerance in reality. Is it even temperature variations or?
Yeah, no. So difficult. Crossrail was definitely the most technically challenging project in the world. The first tunnel project in the world, I suppose, with a new regime for quality. 0.5 millimetre tolerance checked by ourselves, but also because it's in a curve, you're watching the twist, so you could check the width and the height, and you could check all that sort of thing. But the twist was a real killer, because if you were 0.5 millimetre out on the twist, you could have to scrap a whole month's production. So it just needed to be bang on. That's a terrible thing to say.
Would it be unfair to ask were there any panels rejected on site?
No. There was nothing rejected on site. In fact, when you go down the tunnel, you're walking along and there's a 25 millimetre step from one to the next, and you're wondering why the hell do we have to do it like that. So we had the client sent in every 4 weeks a guy with a 3D laser scanner to scan 3 days production to make sure that it wasn't a twist. So we had to set up the whole big area for him, and he had this surveying equipment, and he set up, and there was a 3D survey done on each one, and there was 62 points, I think, on each segment that he checked, and you got the results. It was like the Leaving Cert. You got the results 3 days later to see if you passed or not. But at that stage, you'd already lost a lot more money if you had to scrap anything. So it was, again, you wouldn't have. I've I've never even seen that piece of equipment before. For doing the 3D survey, amazing stuff. Anyway, but there's only four companies in the world that do it. So, the next tunnel he'll be working for us. But once we did Crossrail, suddenly then we have people from Oman looking for a tunnel, Riyadh, and Egypt, all over the place. So we've helped a lot of people out with sort of tender packages and stuff like that over the last while. Donal was our tunnel manager, and he's a lot of expertise in sort of pricing tunnels and stuff. So we at the moment, tunnels in the UK are huge. There's a 47 kilometre tunnel, is not even on the list. 47 kilometre tunnel up in Sunderland, the Potash Tunnel. I don't know, did you ever hear that one? Yeah, massive project. The Humber Tunnel, for 3 kilometres underneath the Humber. Tunnelling is huge, and at the moment we're not making any tunnels, but it tends to be on a project by project basis. So, really interesting stuff. But Crossrail will probably be the most difficult ever.
The project you mentioned in the UK, what contract were you working on?
It's the NEC.
It's for the NEC3.
NEC3, isn't it? Yeah. We actually, most projects we would work on, unless it's a really large project, we would work on just a purchase order. You can have a £3 million pound project and not have a contract at all, in terms of your NEC type. But where we have some installation element, or if you sort of see projects that are over sort of I suppose 3 or 4 million, you tend to see the NEC being dragged out. I don't usually go to those meetings, so there's another guy who goes to those meetings, because you go through a few of them and then it's the same, and they're all worried about the same thing. But we tend not to try to, we tend not to get contractual with clients. We try to, again, the clients like collaboration. NEC3 is quite, I suppose, rigid, and the clients need to understand that they need us on the next project. So it's not a case of, well, we're going to screw you in this one, and you're going to, we're just not going to supply you on the next one if you screw us on this one. So it's quite a good situation to be in, I suppose, these days. So, yeah.
Any final questions from the floor?
Just on the Crossrail there, the 36 GGBS, does that make much of a difference to your production and timelines? Delay it or
I mean, we worked a lot on the mix design. What do we do? We worked with steam and worked a lot with the temperatures, temperature monitoring under the standards. We heated the water going into the mix, so we got the temperature coming out of the mixer at 28 degrees, and then managed that upwards slowly, so that we got the temperature. So you were looking for stripping, you were looking for 19 newtons on 11 hours, and it was a challenge. It was really simple, because normally with concrete there's some give or take. If you need 19, well, sure, you'll get away with 12, because Steve's got 1.4 and 1.2 and all sorts of safety factors in it. It's funny with tunnel segments, if you don't have 19, it just breaks. So you quickly learn not to once the Smith hammer hits 19, lift. But if it's 18, don't lift. So there was a lot of time spent on the working on the mix. We got some help from Ecostem on that. I better acknowledge the boys. And but I don't think that anybody expected us to be lifting that quickly. And the client spent 8 weeks with us monitoring. with 3 people on site all the time, just monitoring the temperatures and making sure that we could get the 36, we could get it to work with the 36%. So it was through a combination of heat of the mix, heating, and then steam curing that we managed to get it through. But the document that was produced for the operational procedures for how to do that were just massive. Sensors in every segment that was poured in the second cast every day was sensors in it, just to verify that everything inside was exactly what we expected on the outside. So yeah, certainly a challenge.
The GGBS can be a bit of an issue for pre-stressed beam design as well too. GGBS has a slower strength gain than your standard, your Chem 1 type concrete. So for pre-stressed beam production, that's significant, because really we're really not that concerned about the 28-day strength of pre-stressed beams. We're really interested in the strength at the application of transfer. So if that slower strength gain with the 36 GGBS, it can delay the time lag from casting of the beam to when we can release the pre-stress. So yeah, for pre-stressed beams, it can be significant enough.
Yeah, in terms of your pre-stressed beams, you know, we're working on hours. So if because production is just crazy, if you know you're going to reach, if Steve's design's got 50 and you know you're going to reach 50 on 31 hours, well then it doesn't matter if that's 2 o'clock in the morning or 1 o'clock in the morning or whatever time. That's when the shift starts to go on detention, because production is, you know, 24 hours a day. It's just crazy with the level of production that's required at the moment. It's probably as busy as it's ever been. The 2 projects that we're working on at the moment are Aberdeen 57 structures, there's 1,200 bridge beams in that, and then this Mersey Gateway, which is the 256 beams, but as I think 160 of them are more than 100 tons each, so with 90 cables or something like that, you know, they're just crazy stuff. So you're trying to ram them through the factory at the moment, and we're doing the Norwich bypass, another 12 structures. We're doing we're doing another A6, is it? I know, it's just crazy. Beams are mad at the moment, on all sizes. So you're watching the strength. You know, the nightmare is somebody specifying 36% GGBS in the bridge beam mix, which you can have, but it comes at a bit of a price increase on that because of that delayed setting, and it's not easy to do the level of stuff we did for Crossrail, heating the water going into the mixer. Steam curing is not just as easy to do in sort of long line bridge beam production, where the lines are 200 meters long, and so it's just certainly not as easy to do that, you know.
Any last question before we make some final comments? Or? Okay, well,
That's good. Thank you very much.
Thank you very much.